Next problem. A random sample of 100 articles selected from a batch of 2000 show that the average diameter of the articles is 0.354 with a standard deviation 0.048. Find 95% confidence interval for the average of this batch of 2000 articles. We'll see the solution. Given sample size n is equal to a random sample of 100 articles, so n small n is equal to 100. Sample mean, so average diameter, right? Sample mean diameter, that is mean diameter, that is sample mean x bar is equal to 0.354, and standard deviation for the sample small s is equal to 0.048. They have given the random sample of 100 articles selected from a batch of 2000 articles, so that is the large population. So population size capital N is equal to 2000, right? So the 95% confidence interval for the average population is, the formula is x bar plus or minus z alpha, that is z value at 95% confidence, right? Small s by n, capital N minus n by capital N minus 1 within square root. So this is type 2, right? Here small sample size and population size also given. So in the previous cases the sample size is given, right? In the previous cases sample size small n is given, but capital N population size is not given, right? So this is what we have seen in the last problem. The previous problem sample size was given and population size was not given, right? Here both are given, so note that, that is type 2. So we are using different formula, right? So we know that 95% level of is level value of z alpha is equal to 1.96. Substituting that value, so required interval is 0.354 plus or minus 1.96, 0.048 root of 2000 minus 100 by 2000 minus 1. So after simplification you will get 0.354 plus or minus 0.1402. Take the plus or minus value, so it will give lower limit, plus value give the upper limit of the interval. So 0.354 minus 0.1402, that is 0.2138 lower limit. Taking the plus value 0.354 plus 0.1402, that is 0.4942, that is the upper limit, that is the required interval. Next problem, a normal distribution has mean 0.5 and standard deviation 2.5. Find first one the probability that the mean of a random sample of size 16 from the population is positive. Second one, the probability that the mean of samples of size 90 from the population will be negative. So given population mean, right, a normal distribution has mean 0.5 and standard deviation 2.5. so that is population mean mu is equal to 0.5, population standard deviation sigma is equal to 2.5. Now in the first case, the probability that the mean of random sample size is small n, that is equal to 16 from the population is positive, so we need to find. So to find probability of sample mean is positive, that means sample mean we know x bar, which is greater than 0, right? So to find probability of x bar greater than 0, so probability of x bar greater than 0, that means you subtract population mean from both side of the inequality. So probability of x bar minus mu greater than 0 minus mu, right, and divided by the standard error, that is sigma by root n, right? Probability of x bar minus mu by sigma by root n, which is greater than 0 minus mu by sigma by root n, right? So we know the test statistics x bar minus mu by sigma by root n, that is z, right? Probability of z greater than minus mu by sigma by root n, right? So substituting the value, probability of Z greater than minus 0.5 by 2.5 root of 16. After simplification, you will get probability of Z greater than minus 0.8. So normal curve area greater than minus 0.8. So this one Z is equal to 0. This is Z is equal to minus 0.8. So which is greater than means that side, right? Less than means this side, left side. Greater than means right side. So yellow marked area, right? That is Z is equal to 0. So right side, that is positive side area is 0.5 and negative side area is 0.5 total area, right? So total normal curve area is 1. We have divided into, we split it into 2. So positive side 0.5 area, negative side 0.5, right? So we need yellow shaded area value, right? That yellow shaded area can be written as minus 0.8 to Z is equal to 0 area plus that positive side, that is right side area, right? So total right side area 0.5 plus this area between minus 0.8 to 0, right? So that can be written as 0.5 plus probability of 0 less than Z less than 0.8, because normal curve is symmetric and the negative side area is equal to positive side area. So that is what we are using, that property, right? So this area is nothing but this area, right? So we are using that one. So from the table we will get probability of 0 less than Z less than 0.8 is equal to 0.2881. So answer is 0.5 plus 0.2881, 0.7881, right? Hence the probability that the mean of a sample size 16 will be positive is 0.7881. Second case, sample size n is equal to 90 they have given. So here sample mean is negative, that means x bar is less than 0. So using the same idea, subtracting population mean on both sides, so and divided by the standard error sigma by root n. So you will get probability of x bar minus mu by sigma by root n, that is nothing but the test statistic CZ, and we know the value of mu, sigma, n, and substitute those values, right? Probability of Z less than so z minus 0.5 by 2.5 root of 90. After simplification you will get probability of Z less than minus 1.8975. So this is same like previous, right? So Z is equal to 0. So here Z is equal to minus 1.8975. So this is the area less than, Z is less than, so the blue shaded area, right? So right side area 0.5, left side area 0.5. So this can be written as left side total area, that is 0.5 minus Z is equal to minus 1.8975 to Z is equal to 0 area, right? We can subtract that one, you will get the dark blue shaded area, right? At 0.5 minus probability of minus 1.8975 less than Z less than 0. So 0.5 that is same like the positive area, probability of 0 less than Z less than 1.8775, right? Not 1.42, that is wrong. So you have to write it, rewrite as 1.8975. So that area is, this is like this. So yeah, both are equal. So 0.5 minus 0.4706, that is equal to 0.0294. Hence the probability that the mean of the sample of size 90, not 900, will be negative is 0.0294. Small typo error is just you correct it. Thanks.